Okay, so here we have some electroscope questions, and here is our handy dandy electroscope. Alright, and it has a metal ball and metal leaves at the end. And when a negatively charged rod, as you'll see in the picture here, is brought near the top of the electroscope, the leaves fly apart. Okay, so the ball here, this guy, and the rod and the leaves are made of metals. So is this a conductor or an insulator? Well, metals are conductors, which means they allow the electrons to flow, and they therefore allow a charge to flow through them. While the negative rod is near, is the ball positive or negative? Well, this system, the electroscope, right now, it's neutral. Now, if we bring a rod next to it, where are all of the positive charges going to want to go? Well, opposites attract, so they're going to want to go towards this negatively charged rod. Therefore, all of the electrons in this system are going to want to run away. So they run away out to the leaves of the electroscope. Alright, so while the negative rod is near, is the ball positive or negative? Well, it becomes positive. Alright, so we're shifting our charge here. Why exactly do the leaves fly apart? Well, they fly apart because the negative charges shift downwards, and both of these leaves are negative. This is negative and this left side is negative, and two negatives are going to want to repel each other. So the negative charges shift down, both leaves are negative, and they'll repel. Alright, so the electroscope is currently charged by, now we haven't charged it by contact. We haven't touched the electroscope with the rod. We haven't introduced an alternate path for any of these charges to go. We are just shifting our charges. So this is known as separating charge by polarization. We're polarizing the object. Alright, so here it says, if I rub the electroscope with the charged rod, the leaves stay out. Why? Alright, so now we're talking about this electroscope, or this rod, actually coming into physical contact with the electroscope. Now, if the rod is negatively charged, and these are all metals, therefore they're conductors, this whole electroscope is going to, as a system, become more negative. And we have physically contacted the rod to the electroscope to transfer a charge. So this is called charging by contact. Okay, so the leaves continue to stay out, and E, we actually jumped ahead right there. E says why. So why are these still apart? Well, they're both still negative, and they're both alike, so they're going to want to continue to repel. So they're both still negative. Alright, how do I get the leaves back together? So how could I get these leaves to chill out a little bit? Well, I could ground it, so I could take the electroscope and touch it to a pipe, or there's a minimal charge here, so it's actually enough that if we were to touch it, we could ground it that way as well. Pick a little bit darker color. Alright, so we could ground it. Or we could touch it to ground it. Alright, so grounding it in the traditional sense, putting it to a pipe, or we can touch it ourselves to ground it. Alright, so the electroscope is neutralized. We have grounded it. The negative rod is brought back close to the electroscope. So think about back to this first image here. So right now we just have polarization. Okay? And this is like the demo that we did in class where we had the two spheres, right? And they were touching, and we neutralized them first and then brought the rod next to it. Well, this is negative, and this becomes more positive, this left sphere, and all of the electrons run away to this right sphere. When I take this right sphere away, well, I've provided an alternate path for these electrons to go. So now I just have a positive sphere. When I used to have two neutral spheres, I separated it at first by polarization, but then by contact I was able to get the electrons to go over here, and then by induction I provided this alternate path. Okay, so this is similar. The electroscope is neutralized, the negative rod is brought back close to the electroscope, like this, alright, and we've separated the charge just like we did in the demo. Alright, and this time I put my finger on the electroscope. So I put my finger on the electroscope. What happens? Well, the electrons are going to flow through my finger out of this electroscope, and the electroscope will become predominantly more positive. So the whole thing will become more positive because it's lost some electrons. Alright, well, these leaves here are now both positive. So now, although they have a different charge, they're both still the same as before, but they have the same charge now. They're both positive. So they're going to continue to want to repel each other. So what happens? The electrons, call them E's, leave through induction to your finger, and the electroscope becomes positive. The leaves are both positive, so they continue to repel. And there's actually this really neat video online that we can watch here. Now this person has the same setup. He has this rod and he has fur and this electroscope here. Now we're going to see all three types of separating charge here in the next few seconds. Alright, so now he is separating charge by contact, by rubbing the fur. And then here you'll see by polarization he's getting the positive charges to move towards his finger, and the negative charges, we'll back up a little bit. The negative charges are now at the bottom and they repel each other. Now this is polarization. You're shifting the charges. So negative, negative, negative in the rod. The ball here is positive because these opposites are attracting. And all the negatives that were in this neutral electroscope run to the bottom. And these leaves are both negative, so they repel. Now this man is about to, while the rod is near and he has this polarization going on, he will touch the ball of the electroscope and the electrons will leave the electroscope into his finger. It's very interesting to see what happens. The leaves close up, but then whenever he removes the rod and his finger, they repel again. So this whole system is now positive, and then you'll notice he touches it and grounds it, and the leaves mellow out a little bit.